Hello and welcome back. We are in section 4.1 and we're talking about rational expressions and rational functions. On problem 3, we are given a function f of x equals x plus 6 all over x squared minus x minus 6. And it asks us on part A to evaluate f of negative 1. So remember, we're taking out the x and putting our negative 1 in place everywhere we see our x. So on the top we have x plus 6, so we'll put negative 1 plus 6, and then on the bottom we'll have negative 1 all squared, make sure that's all in parentheses squared, minus negative 1 minus 6. And then let's simplify what we can here. So on the top, negative 1 plus 6 is 5. And then on the bottom, we have negative 1 squared is 1. And minusing a negative is really adding. So plus 1 and then minus 6. So that gives us 5 over 1 plus 1 is 2 minus 6 is negative 4. So f of negative 1 is negative 5/4. So you won't always come up with a whole number answer, especially on these type that have fractions in them. To start off with, they could end up with fractions in their answer. All right, let's take a look at the next one. This time we're asked to evaluate f of 6. So instead of putting negative 1 in this time, we're now going to put 6 everywhere we see an x. So let's do that. That in place of x, and then when we simplify this, on the top 6 plus 6 is 12, in the denominator 6 squared is 36, and then minus 6 minus 6, so we get 12 over 36 minus 6 is 30, minus another 6 is 24. And so if I finish simplifying that all the way, I'll get 1/2 for my answer there. All right, so you've seen this type of thing before where you are evaluating. It's just now we're going to have some fractions in there, and that is just fine. All right, the next thing that we want to talk about in this module is all about how to simplify rational expressions. Now, a really important thing to keep in mind, this whole unit, you've got to remember how to factor. You are going to use this a lot. So let's look at the steps for simplifying rational expressions. First, we're going to determine what the restricted values are. And specifically on this, since we're dealing with a fraction, we're trying to figure out what values make the denominator 0. On the second step, we need to factor both the numerator and the denominator. So we can't do any kind of simplifying until we factor. Then we need to identify common factors in the numerator and denominator. And then the fourth step, we can simplify by removing all factors equal to 1. So if there's a common factor on the top with a common factor on the bottom, we can divide those out to be 1. Now, in this caution box, this is a common mistake when you're simplifying rational expressions. Notice here we have x plus 5 over x minus 3. Well, one thing that happens is a lot of students think, oh, I can just divide those x's out, and those will become 1s. You can't do that because it's connected by addition and subtraction. And the only reason why we could, if it was connected by multiplication, if it said this, they were connected by multiplication, then yes, then those x's would divide out because we're saying x divided by x is 1. But that's not the same thing that this is saying here, so be really careful on that. The whole factor needs to be divided out. Let's see how that works here on this one. First off, we need to determine our restricted values, but that's actually going to be easiest to do if we factor. So let's go ahead and factor. Sometimes it's already in factored form and so we can see it easily. But if not, let's get it factored so we can see what those restricted values are. So on the top, we got y times y, and then what times what is negative 3 that adds to be positive 2? Well, that will be a positive 3 and a negative 1. On the bottom, y times y gives me the y squared. What times what is 2 that adds to be negative 3? That would be negative 2 and negative 1. So now that it's in this factored form, I can see what those restricted values might be. So let's list those here. So remember, it's the values that are going to make the denominator 0. So if I put 2 in place of y, 2 minus 2 gives me a 0, so 2 is one of my restricted values. And if I put 1 in place of y, 1 minus 1 is also 0. And so those are the two ways that we would get 0 in the denominator, and that's what we can't have. All right, let's go ahead and divide out then, and I can see I've got y minus 1 and y minus 1 are common factors, and then when I divide those out, I end up with y plus 3 on the top and y minus 2 on the bottom. Now, can I just divide those y's out? No, just like I said up here, we cannot do that. So be really careful with that and make sure that you are seeing that this is your answer. Y plus 3 over y minus 2.